Good morning and welcome to Edgewater Ranzel's webinar series. Today's webinar is titled Modernize Your Analytics Approach with Oracle Big Data Discovery, and it is hosted by Dan Brock. Our webinar series targets specific customer interests related to business analytics solutions that include Oracle Hyperion Enterprise Performance Management, Business Intelligence, and Big Data. So we'd like you to email us at seminars@ranzel.com with topics that you'd like to see covered. During the presentation, you may submit questions in the right-hand panel on your screen. Just type the question in at any time, and we will address it at the end of the presentation. Edgewater Ranzel is a full-service Oracle Platinum Consulting partner that delivers innovative solutions to clients that solve an array of business problems and maximize the effectiveness of their strategic, operational, and financial management processes. We remain connected to the design and development of new and changing Oracle products and technology, and consistently apply and update leading practice methodologies that address changing business requirements and take advantage of evolving system capabilities. Our worldwide team of over 200 employees has years of industry-specific experience, certifications on various Hyperion applications, and includes Oracle ACEs, who are recognized experts in their subject area. Services we provide support all facets of Oracle Enterprise Performance Management, Business Intelligence, and Big Data Solution Delivery, including consolidation and reporting with the Financial Close Suite, enterprise planning, profitability and cost management, and business intelligence applications and technology. And we offer supporting services for infrastructure, data services and integration, training and support services, and project management. For additional details about Edgewater Ranzel, visit our website, www.ranzel.com. Our recent company highlights include the acquisition of M2 Dynamics, an Oracle Platinum partner that provides Oracle Enterprise Performance Management and Business Intelligence solutions and services primarily to the West Coast and southern regions of the United States. M2 will join Edgewater Ranzel in providing clients with IT consultancy services specializing in business analytics and encompassing EPM, BI, and big data solutions. For the second year in a row, Edgewater Ranzel has been recognized by the Commonwealth Institute and More Research as the 5th largest woman-led business in Florida and is ranked in the top 10 for each of the last 4 years. Edgewater Ranzel recently acquired Chicago-based Branchburg, an Oracle Gold partner specializing in big data and data discovery technologies and solutions. This acquisition provides Branchburg with the infrastructure to rapidly expand their offerings and helps Ranzel to expand its reach into emerging Oracle Big Data space. Edgewater Ranzel recently introduced Ranzel Healthcare Analytics, a comprehensive solution for healthcare providers that integrates with data found in the Oracle Enterprise Healthcare Analytics platform to help meet fundamental needs such as financial reporting, operational analytics, decision support analytics, planning, and costing. Finally, Edgewater Ranzel has achieved Oracle Validated Integration for its integration of Ranzel Healthcare Analytics Costing 1.0 with Oracle Enterprise Healthcare Analytics. Today's presenter is Dan Brock. Dan recently joined Ranzel as a part of the Branchburg acquisition, where he was a co-founder and principal. Currently, Dan is heading up Ranzel's Big Data Analytics practice. Dan's original passion for big data started back in 2007 when he was a solution architect with Endeca, where he designed and implemented a number of Endeca's most successful and referenceable solutions. After Oracle's acquisition of Endeca in 2011, Dan moved into a product management role where he focused on evolving the data discovery capabilities of the product and integrating it into other existing Oracle products. In his current role, Dan is ensuring that his big data practice is making heavy investments in Hadoop, as well as how to best capture the benefits of the rapidly converging discovery and big data disciplines for Ranzel's customers. Dan?
Hi everyone, good morning and thank you for joining. I just wanted to take a little bit of time today to talk to you about where we see our customers headed as it relates to modern data architectures in the big data space. Architectures that are multi-tenant, that can serve a variety of needs on a common and ubiquitous platform. So before we dive into all that and exactly what customers are doing in the space, I think it's very important to understand where the big data journey has come from and where it's headed. So I want to spend a little time today talking about the traditional approach to analytics, namely in the business intelligence space. And I want to talk about some of the challenges of the traditional approach, where we found it was ill-equipped to deal with some of the demands of big data, which led us to the advent of Hadoop, a data operating system and big data foundation. And even once Hadoop started to flourish, and it's still very much in its infancy, but we've noticed that there's even some challenges getting Hadoop completely adopted inside the enterprise. So that's going to segue our conversation a little bit into how Oracle is addressing additional needs for organizations that are starting to embrace Hadoop with the advent of a new product called Oracle Big Data Discovery. We'll spend a little bit of time talking about how Big Data Discovery squarely addresses those challenges, and to start to talk a little bit about how it does what it does under the covers, and how, lastly, the product can be used in your organization to deliver some of the promise of big data. So with that, I want to just dive right in and talk a little bit about the product itself before we talk about the chronology of how we got where we are. So Oracle Big Data Discovery is a new product for Oracle that released in the spring of last year with its initial GA version 1.0. I call it a new product, but in a lot of ways it's built off a very sound foundation as the evolution of the Endeca DNA. So a lot of the underlying core code was evolved from Endeca, but it has certainly been replumbed for a big data architecture and to complement a big data architecture. At the moment, the current version of the product is 1.1.1, so it's quickly evolving with minor releases to improve upon and make the product more robust and production ready. Joey introduced Branchburg as a recent acquisition of Ransell. In the spring of last year, Branchburg was the first and only Oracle Big Data Discovery beta partner, which gave our organization early access to the product. And we worked very closely with Oracle and Oracle's product management group, providing feedback and helping them address challenges we had with the product so that it could be ready for customer consumption upon release. But with that, let's try to understand a little bit about where the need of the product came from. So let's talk about the traditional approach to data analytics. And we're going to talk about that somewhat specific to the data warehouse. And I know that may be a little narrowing the scope a little bit too much, but for a lot of organizations, a data warehouse or a data mart is very central to their analytics approach. And this isn't to suggest that this approach isn't still necessary. We find it very necessary, actually. This is the infrastructure you're going to need to curate the right data sources in your organization, to ask the right questions, to understand the health of your business, to measure that health. So we're not suggesting that this approach needs to be replaced, and we're not suggesting that this approach isn't still suitable today. But it does need to be complemented with a new approach, and we're going to talk about what the impetus for that new approach is. So if we hone in on this traditional approach, it's really three pieces. It's ETL, it's warehousing, and it's reporting, and those happen subsequently. I think I'm going to make the assumption that most of the attendees on today's call have a high level appreciation for that process, so I'm not going to try to get into too much of what it specifically is. But at the highest level, we're ETLing the data, or extract, transforming, and loading it, which means we're picking it up out of source systems, and we're moving it into a common data warehouse, a common database, where we massage and normalize the data. So it's a cleansing activity, and then we're changing the way in which we store the data and the table structure in which we store that data so that we can report on it efficiently. And then once the data is a platform for reporting, we put a reporting layer on top of it so that we can publish and disseminate reports within our organization. And these are producing the measures, the KPIs, the questions we know we need answers to measure the health of our business. So this approach certainly offers some challenges, certainly as we've seen the world evolve into one of big data, where we're getting access to more data sources than ever at volumes that were previously unimaginable. And for a number of years, a lot of organizations continue to try to solve these new challenges of big data with their existing tooling, with their existing traditional approach to reporting around the data warehouse. And some problems emerge when you try to solve those big data problems with your existing approach. First and foremost, there's by its very design, there's a rigidity to organizing data into a database. Traditional databases are organized with tables, and those tables have predefined columns and fields. So you definitely have to massage the data to fit within a certain structure, and that offers a certain rigidity. So it's not always easy to accommodate new sources of data, especially the ones that we see evolving outside of the four walls of our enterprise. We're seeing a lot of interesting and a wealth of data that comes in unstructured forms. Data services offer JSON, obviously, which is a self-describing way to offer data. We see images. We see all sorts of data formats that don't necessarily fit nicely into tables. So that kind of segues to the second point, where we don't see a lot of support for data variety. Now, there's certainly, if you put enough effort and time into your data warehouse, you can certainly get that data to fit, but it's costly. So we talk about it being tough to get data in, but once it's there, it's easy to get data out. All of the traditional approaches that all work against a data mart or a data warehouse are working against a single database instance. So there's a very real finite limit to the amount of data we can store and the amount of data we can process, because it's running on a single server architecture. There's been some advancements made by Oracle with Exadata and some of the appliance companies like Teradata and Netezza, which parallelize some of that operation. So we've seen some clever ways which companies have evolved the database to address higher and higher scale points, but ultimately you're still going to hit a ceiling at some point. And that to raise the ceiling incrementally time and time again gets more and more costly, and the cost doesn't necessarily always grow linearly with the scale. And what we wind up with the traditional approach is what we call the BI backlog, which means as we disseminate the reports that come out of the data warehouse to our organization, inevitably the insights that those reports surface are going to beget more and more questions. Your customers are going to come back saying, yes, this report gives me what I need, but I just need this one region filtered out, or I just need to see the sales numbers without this particular county. There's always going to be variations of the reports that they request, and delivering those variations is often an exercise of weeks or months, not seconds or minutes. So we fundamentally need a new approach. So to tee up kind of the paradigm shift that led to the advent of Hadoop, I like to quote a very popular American computer scientist back in the 1950s, Grace Hopper. In those days, even back then, before really the advent of computing as we know it today, she realized even then that we needed a system of computers to really introduce the scale that is going to be needed at some point. So instead of trying to continually put more and more processing power onto single server architectures, we actually need to start thinking about distributed computing, so that our once and for all, in a cost-effective way, our organizations can scale with the data that's going to make us competitive. So I'm sure everyone on the call at one point or another has seen stats like this. We're under a data deluge, and organizations that learn how to put the right architecture in place and the right approach in place are going to have a very clear competitive advantage for how they realize the potential of the data that's available to them. Because most modern organizations realize that data is a commodity. It's a raw material with which you can compete. It is the lifeblood for a lot of businesses, certainly large businesses. So how we tap into and realize the potential of that data is very important to making sure our companies stay relevant and evolve in the right direction. So we're seeing more data than ever, and it's coming in more variety than ever because now we have access to so much data that exists outside the four walls of our enterprise. We have social media. We have, I can't underscore how important the Internet of Things is going to be in the next decade, where companies are now producing smart appliances, smart vehicles, certainly the digital exhaust that comes off of our mobile devices. All of this data is being shipped back to the motherships of the companies that produce those products, and that data can be very actionable if you know how to use it. But there's a lot of it, and it doesn't conform nicely to the data warehouse. There's no question that there's valuable applications to using this data, but it's really only the organizations that spend the time and the effort trying to understand what those uses are that get the competitive advantage. So time needs to be spent understanding how that data can be put to use, and we're seeing it right now that there's a lot of uses in terms of marketing applications, real-time product recommendations, proper use within forecasting. Certainly there's uses around fraud detection, customer 360 or segmentation, and the list goes on and on. Those are just some of the more common uses we're seeing. As I mentioned, we don't know exactly what to do with this data. There's a lot of it. It's unique in its form, and it doesn't fit nicely into our existing warehouse. So what do we do? Well, actually, there's two problems that need to be addressed. There's a storage problem, and there's a processing problem when we start to talk about this much data and this much data with variety. And we need a way to do this, and we can't rely back on what I call the single server or the big server approach. So this is leading us to a new paradigm. We need a distributed computing architecture, and I want to talk a little bit about how Hadoop has emerged to solve this particular problem. One of storage and one of processing. So probably something everybody's seen at one point or another. Just as an introduction, Hadoop is actually completely open source. It's free. It's a part of the Apache open source project, and it was created in 2005 by Doug Cutting and Micah Farella. Doug is actually now at Cloudera as one of their engineering leads. It was actually named after Doug Cutting's son, Stuffed Elephant, which I think most people have heard that anecdote at one point or another. But this new concept was actually inspired by some papers that came out of Google in 2003 around their homegrown approach to distributed computing. So I actually want to kind of talk through the architecture because that's the easiest way for me to convey exactly what Hadoop is doing differently than the approaches we've seen in data architectures to date. So no surprise, we've already alluded to it, but the needed approach is a distributed one, where we're actually, instead of relying on clever ways of raising our scale and compute potential within a single server, we need to rely on a cluster of servers. So Hadoop is built on a cluster of commodity servers, which is why it's cost effective. And it actually scales in terms of both storage and processing as we grow that cluster to more and more servers. So by example, if we start with just a collection of commodity servers, these aren't bleeding edge by any means, modest amount of RAM on today's server scales and a modest amount of compute, we put these servers together into a cluster. And what we're able to do with Hadoop is we're able to take advantage of the local storage on each of those servers. So the more and more servers we introduce to the cluster, the more and more storage is at our disposal. And the first thing that Hadoop does is it sits on top of the local storage on each of these servers and abstracts that local storage to look like a single storage layer. So much like you look at your your C:\\, your C drive or your D drive on your workstation, the first layer of Hadoop is a storage layer, and it's nothing more than a file system. So just like the C drive is a file system on your desktop, HDFS, which stands for the Hadoop Distributed File System, is a mechanism to store files and directories, just like any other file system. But what Hadoop is doing is it's abstracting the complexity of how it brings together the separate local storage from each of the servers in our cluster and making it look uniform. So when we bring a file and we want to save it in HDFS, it's as simple as just putting it into the file system. And when we're navigating the file system, we see the file just like we'd see a file on our C drive. What we don't have to be burdened with is what Hadoop is doing for us under the covers, and that is it knows how to chop that file up into blocks and store that on different servers. So I'm going to get to why that's important, but it actually replicates those blocks too, which isn't really obvious in this visualization. But the reason that's important is if I'm storing copies of every block, and the default copy factor in Hadoop is 3, I can actually have server failure without data loss. Because if I lose a particular server where part of my data exists, I know that that same data has been replicated elsewhere in my cluster. So I can always reconstitute my data if a server goes down. But breaking into blocks has other advantages that I will get to when we start to talk about how Hadoop also abstracts the local compute from each of these servers into a uniform compute layer. And this is really where the paradigm shift, the core paradigm shift of Hadoop exists, is that we still write logic, often in batch form, to execute against the files we've stored in Hadoop. We want to understand, we want to do natural language processing against a big dump of Twitter data to understand how maybe one of our campaigns has been received in the social sphere. We might write a script that parses through a dump from Twitter to understand the effectiveness of our campaign. Well, in a traditional world, I have to bring the wealth of that Twitter data to a single server on a single CPU to run my program. So I'm bringing the data to the compute in the traditional world. The core paradigm shift with Hadoop is I no longer bring the data to the process or to the compute. I bring the program to the data. So I don't bring the data to the program, I bring the program to the data. So you can imagine if I offer that same batch processing script to understand the effectiveness of my marketing campaign against Twitter data, I can take that script to each server where my data exists and run it there in parallel. So now I'm getting performance gains because I can run this in parallel, running it native to where the data exists without bringing the data back together and moving it onto a single server to run. So that's fundamentally tackling one of the main challenges of single server architectures, is that the bottleneck is always moving the data to the CPU. Now we're moving the program to the data and running it in parallel to realize a lot of performance gains. So the two grain tiers you see here are really what we consider core Hadoop. It's a processing layer that knows how to bring the program itself to the data and not the other way around, and the storage layer, which knows how to bring the underlying local storage together into a single file system layer, so we can scale as we put more and more servers together. A lot of the other projects you hear about, a lot of the other big data soup, as I call it, really exists as clients to the core Hadoop operating system. So you'll hear terms like Hive, Mahout, Impala, Scoop, Pig. The list goes on, and Oracle Big Data Discovery, which we're going to talk about in a little bit, is another one of those clients. So at this level, I like to think about Hadoop as a data operating system. We're all familiar with the operating systems of Windows and iOS, and if you really think about what that is, or what those are, they're application operating systems. They know how to run applications. They can install applications, they can uninstall applications, they can execute applications, and they were purpose-built to do that. Well, similarly, as a data operating system, Hadoop was purpose-built to operate on data. What are the type of operations you'd expect a data operating system to do? Well, when I work with data, I want to be able to store it. I want to be able to filter it. I want to be able to move it. I want to be able to transform it. I want to be able to query it. And so a lot of the sub-projects or the other projects in the Apache open source ecosystem that you'll see that often get people confused are really just strangely named utilities that accomplish one of those data operating system functions. Hive puts a query layer on top of your data, so you can throw SQL queries at it. Mahout is a machine learning utility that works on top of your data to derive insights from your data. Scoop is a utility that queries data from source systems and lands it into HDFS for analysis later on by something else. And the list goes on and on. Each thing is producing a new function. And we'll talk a little bit about what function Oracle Big Data Discovery addresses in a little bit. So now that we have a big data and a distributed infrastructure, what are some of the new possibilities that we've allotted our organization? Well, now we've addressed some of those challenges we talked about earlier. We have storage at boundless scale. We have processing at boundless scale. And most importantly, we can process the data in parallel without moving it. We no longer have the bottleneck that exists in a single server, a big server architecture, where we have to move the data to the compute. And we've also relaxed the rigidity of that challenge we saw with the data warehouse. We're storing data in its raw, original format. So in that sense, just like you can save any file type on your C drive, we can save any type of file into HDFS just the same way in its original form. And we're building this architecture with low-cost commodity servers, so we've really reduced the price point in terms of what it takes to get started and what it takes to grow the compute and storage power of our cluster. Okay, so yeah, Hadoop seems great. Like, why do we need BDD? I thought this whole session was about big data discovery from Oracle. Well, it is, and I wanted to set the stage appropriately. But so why is BDD at this point in time critical to modernizing our data architecture? Well, first and foremost, if you go out and see some of the surveys that have been conducted around Hadoop in organizations that are using Hadoop, you'll see that a lot of organizations are complaining that they realize that Hadoop is very powerful, but they don't always have the right people or the right tooling to maximize the potential of that distributed or modern data architecture. So the tooling's not familiar. They don't always have the right people that know how to maximize or unlock the value in the operating system. And they realize that most of the effort involved with data science and data analytics is related to wrangling data, to picking up and understanding the potential value of a data set before I actually do something with it. And when the data isn't perfect, I often need the means to make incremental improvements to a data set before I can actually make it actionable. So I don't have the right people. I don't have people that have the skills necessary to maximize or leverage all the utility that's available to me in the data operating system of Hadoop. And I don't have the right clients that allow me to most effectively deal with data uncertainty, to know what data I have, to understand what data is garbage, what data is gold, and to make that data quickly actionable. So this requires a fundamentally new approach to not only data analytics, but also to big data architectures like Hadoop. I often talk about big data discovery like I talk about Windows. You've already heard me make the operating system analogy, but when we actually think about Windows, Windows wasn't the operating system necessarily. DOS was sort of the beginning of that operating system. What Windows was a single intuitive visual user interface for that application operating system, which was DOS. So really what we need is a user interface that's intuitive, that helps me make sense of what I have inside of Hadoop. What's in my data lake? What data sets do I have? Which ones are garbage? Which ones are gold? Which ones need a little bit of TLC, a little bit of transformation to make them very usable? And if I can make those data sets usable, do I have the means to graduate that into a dashboard so my end users can actually interact with the data and derive insights, mash that data together and really find value in what was otherwise just sitting stagnant in my data lake. Often you'll hear people coin that stagnant data the data swamp, because if you don't know what to do or you don't have a plan to deal with your data lake, it can quickly turn into that data swamp. So I alluded to this, but as another client to that Hadoop operating system, Oracle Big Data Discovery gives you some of those core features and functionality you'd expect to maximize the potential of that architecture. So I'm going to go ahead and play this out, but we really need 5 capabilities that work seamlessly together in that single intuitive visual user interface. I need to be able to find the data in my data lake. I need to be able to explore it, which means I need that data profiled. I don't necessarily know what data that I've landed in Hadoop is valuable. I need to be a way to see what's there, but once I've located a data set, I need to see what fields are in it. I need to see if there's cleansing that's required. I need to see how much null or null values may be contained in the data. And I need to be able to tag that data to say, who owns it, has it been manipulated, what's it related to, what source did it come from? And doing so makes that collaborative. I've now kind of made my data lake understandable to a number of analysts in my organization. They can see what's there, they can see what's been worked with, they can work together on improving those data sets and moving the ball forward. Transform shouldn't be undersold at all. This is a very powerful capability that exists natively in Hadoop, but you bringing that to an intuitive user interface is extremely powerful. Building transformations that run across your cluster can run very fast because we're leveraging all the underlying compute to execute those transformations in parallel. So as I'm finding data sets and I'm exploring them to figure out which ones are going to be most valuable to my analytics endeavor, I may find certain things I want to clean up or transform along the way. And being able to do that natively within my UI is extremely powerful because I can do it right there on the spot, and Big Data Discovery already orchestrates how to pass that data down to the cluster to run the transformation for me very quickly. And then leveraging the boundless scale of the cluster, I can save versions of that data set back for other people to work with and to evolve over time. And then we want to be able to discover. I mean, that's the core capability we're after here with Big Data Discovery. But some of those steps leading up to discovery are necessary to get us to a point where we have data sets that we trust, and we want to bring certain data sets together in terms of a data mashup to drive out new insights. And I need a lot of capability to make that discovery process effective. And this is really where a lot of that core Indeka goodness has been evolved. But it's also the data discovery capabilities of Indeka have been retained in Big Data Discovery. I need to be able to search the data. I need to be able to filter the data. I need powerful visualizations that show me certain insights in the data. And I need to be able to relate and correlate disparate data sets to drive out new insights. And then this is a collaborative platform, so I want to share those insights back to the right people in my organizations and let them possibly take over and evolve my own analysis. So that's what we're looking at with Oracle Big Data Discovery. It's the necessary client to your Hadoop investment to make sense and demystify your data lake. It's a single interface to really allow more people in your organization to make use of and drive meaning from all of the power that is contained within that Hadoop operating system. So we're going to take a quick look at what BDD looks like as it relates to each of those capabilities. And then we're going to talk a little bit about who you should expect in your organization to be using it and what specifically it's doing under the covers. So real quickly, we're going to talk about those specific capabilities. I'm not going to go into too much detail. Certainly if there's questions about any particular one of these 5 capabilities, please put your questions into the chat, and we'll try to get to that at the end of the call when we get to our Q&A session. So we talked a little bit about find. This is really powerful because oftentimes when I'm starting my analytics journey, I don't always know what data is at my disposal. Hadoop is a fantastic way for organizations to capture and store data at low cost. But if you're not able to understand what's been stored, oftentimes that data lake turns into a data swamp, as we talked about. So having this find capability where I can actually use a search box to look across the metadata of my data sets is really powerful. It helps me understand what data I've sunk into Hadoop. When was it last used? Who was it last used by? Has it been transformed? Where does it come from? Is really powerful, because in very quick and short order, I can hone in on the data sets that maybe are just specific to my group or my organization, and I can quickly see what's there and what I can actually derive value from. Part of this data journey that big data discovery allows is also about failing fast. So if I don't find something, at least I'm going to know right away. I can know in minutes that I need to go elsewhere, maybe outside the four walls of our enterprise, and go grab something new, rather than hunting endlessly, sending emails, asking other people, do we have this? Once this is all consolidated in Hadoop, I'm going to know in seconds if I have it. Once I find something that looks interesting, I actually need to profile the data and crack it open, if you will, and take a look at specifically what's there. And this is a very powerful capability of big data discovery, is that once I've grabbed a data set, I can quickly look at each field. And you can see here that big data discovery has prescribed a visualization that helps me understand the data contained within that field. So if it's a date field, I might see a line chart that shows the distribution across time. If it's a discrete field like a string, like region here, it might just show me a histogram showing me the distribution of the values within that field. You can also notice that there's a bar underneath each field that shows you how populated that particular field is. The black represents null values, which is also very important, helping me understand if this particular data set is garbage or gold as it relates to my investigation. Oftentimes, as we go through this data wrangling process that we're really driving down, we talked earlier about 80% of the time that organizations spend is data wrangling and massaging, just the prep that goes into analysis. Within a matter of seconds or minutes, I've already arrived at really what data sets I need to be working with. In a lot of cases, I may find that the data set's pretty much how I need it, but I might need to derive some new fields, or I might need to clean the data a little bit. And that's where this third capability, transform, comes into play. Within the same interface, I can take that data set and introduce a transform screen that allows me to take advantage of an extensive library of pre-built transformations that will probably cover 90% of what you'd ever want to do with a data set. But it also gives me the ability to write my own. Through some lightweight scripting, I can actually build some of my own transformations rather, to prep the data as I see fit. And once I transform the data, it may be a petabyte worth of data in this file. I can run that transformation back leveraging the compute power of my Hadoop cluster and run it in a fraction of the time I could run it in any other single server or big server architecture. So it's a responsible client, big data discovery is to Hadoop, because it's always plumbed and positioned to leverage all the underlying compute and storage power of the cluster. Now, once I've transformed a data set, I'm going to want to graduate that into a discovery dashboard. Just looking at it in kind of an Excel mode where I see rows and columns isn't enough to actually help me understand data in the aggregate. I need to understand the trends in the data. I need to possibly mash that together with other data sets to drive out new insights, and that's what the discovery capability allows me to do. I graduate those data sets. I bring disparate data sets together to have a interactive dialogue with the data, so that I can expose that dashboard to other users in my organization so that they can come to the data and derive their own insights. So here's where I'm going about not coding, but I'm composing that dashboard experience, putting the right visualizations in place, putting the right components in place to tell the story I want to tell for my data. Now, this discovery capability comes with a lot of visualizations pre-built, but it also has an extensible framework at your disposal, so you can very easily go and grab D3 or other JavaScript-related visualizations that can really tell the right story for your data. So if you don't see a visualization that tells the story of your data the right way, you always have the potential to go and grab some of those pre-built. D3 is my favorite visualization library. Bring those visualizations into your big data discovery application so that you always have the potential to put any visualization into your dashboard that you want. And then the fifth and final capability we're going to cover is around share. This is about helping others see how you arrived at the insights you arrived at, what data sets you brought together, building galleries that basically provide the snapshots that kind of show which specific insights you might want to share with others. Allows you to create bookmarks so that others can dive into the data at a particular place where you saw something of interest, and it allows you to save the data back to HDFS so that others can pick it up down the road. Okay, so it seems pretty powerful, right? It really does take Hadoop, which is otherwise a command line operating system, much like DOS was as an application operating system, and it democratizes access to all that powerful analytical capability to more people. I'm not suggesting everybody in your organization is going to be able to use it, but certainly your business analysts are going to be able to take advantage of the power of Hadoop as they endeavor on their analytic journey. So what's BDD actually doing under the covers to accomplish this? So BDD is composed of three components. Studio, which is what you guys saw in the screenshots, that's the visual front end. There is an in-memory hybrid search and analytical database. So as each data set lands in Hadoop, BDD is going to detect the data that has landed. It's going to pick it up and profile it. So it's going to understand the metadata about what data landed, but on a field-by-field basis, it's going to profile it. So it's going to understand what's contained in the data set. Are there a lot of nulls in a particular field? What type is it? So that you can easily explore your data lake and figure out what data might be helpful in your analytical journey. And then where a lot of the engineering investment went into this product is actually at the last tier here, the data processing tier. The product is very well integrated with Hadoop, specifically within the Spark tier of Hadoop. So Spark as an option for your compute tier of Hadoop is a very powerful data transformation and data query language, and it integrates with Spark natively without your analysts having to worry about how to write Scala for Spark to accomplish certain tasks. BDD is doing all of that for you. Certainly that's important when we profile the data. Spark is being leveraged under the cover to interrogate your data sets, but we saw that transformation capability as well. All those transformations get passed down to Spark across your cluster so that those transformations happen in parallel and very quickly. So when we deploy BDD, I want to talk a little bit about the architecture. I apologize, this slide actually doesn't look quite as it used to, but I think it still conveys what I intended. But when we look at a cluster of servers that is built for Hadoop, we're usually looking at these utilities being installed within that cluster. So if we look at just a single node, on that node, we're going to have HDFS, of course, and then we're going to have a lot of the analytic and data processing tools, which, if you don't have BDD, require command line knowledge, unfortunately. And there's certainly people out there that know all of that, but we call them four-leaf clovers because they're very hard to find. So, within the cluster, I have Spark, MapReduce, Scoop, MLlib. The list goes on and on. A lot of those data operating system utilities that help me work with the data. Now, when I introduce BDD, I'm introducing what we would call another edge node, a client to the cluster. But that client knows how to work with all that tooling in a very integrated fashion. So I look at my Hadoop node and I look at my BDD node. My BDD node is going to have Studio and the dgraph server on it, which gives me that interactive experience that you saw on those screenshots previously that accomplishes my find, my explore, my transform, my discovery, and my share capabilities. But it has, back on Hadoop, it integrates with its own client, BDD data processing client, so it's always working with the underlying compute and storage capability of the cluster. Okay, so quickly, how does BDD know what data sets have landed in my data lake? Well, I'm not going to get into too much of it at a low level, but we talked about BDD's constantly listening, if you will, for new data sets. So we can schedule a listener, if you will, that is detecting when new data is being registered in H catalog. And once that new data lands, BDD is going to responsibly go in, pick up that data set and profile it, and then catalog it so it can be explored later in that interface. I'm going to skip through that, but so let's talk a little bit about how customers are using BDD. There's really two distinct ways that we see customers gravitating towards the capabilities of big data discovery. First is around what we call demystifying the data lake. This is really the use that customers that are already using Hadoop are gravitating towards, because what we're seeing is a lot of customers that are using Hadoop are getting a little bit frustrated by how difficult it can be to leverage all of the utilities that are available within the data operating system. There's only a few people that they can possibly hire, or a few consultants that they can find that can really make meaning of those utilities, and maybe they only know a handful of them and not all of them. So they're really struggling to understand what data is landing in Hadoop, what of that data is valuable, how they can transform that data and graduate it into a meaningful discovery experience. Doing all that requires just an enormously broad skill set, and that's where BDD is helping these organizations demystify their data lake, but also kind of establish a data laboratory, a place where their analysts can go and experiment with diverse data sets and shrink the time it takes to prep and mash together data so that they can fail fast and drive out new insights in time frames that were otherwise unimaginable. The second way we see companies gravitating towards big data discovery are those companies that are interested in building big data applications. So we call a big data application really a discovery experience, a discovery dashboard that's been operationalized. Organizations might build a dashboard they realize unlocks a lot of value for their organization, and they may want to move to make that dashboard permanent. So Ransell can come in and help customers operationalize, keep the data fresh that drives that discovery experience, put the right security and visual interface in place in short order so that they have a 24/7 discovery experience that can be leveraged by any number of people in the organization at all times. That's really a really powerful way to leverage the product. So that's about all I plan to cover as it relates to where Ransell has seen its customers headed and where they've been and where they're going as it relates to their big data architectures and big data journey. So I would encourage you to reach out to me directly if you have any questions about what we've seen here today. And at this point, Joey, I'd like to see if there's any questions that were captured in the chat, or if there's a way to unmute the participants to ask questions. Thank you for your time.
Thanks, Dan. We are. I noticed we're actually coming up on the hour here, so I just wanted to make a note that any questions that have been submitted, or anyone who has questions to submit, may be emailed to seminars@ransell.com, and we will respond to you directly. A recording of this webinar will be available on our website shortly, where you may also find a number of previous webinars posted. Our webinars cover a range of topics, so we encourage you to visit our website to view upcoming webinars that you may find valuable. Our next webinar is on January 21st, and its focus is on strategic planning for the oil and gas industry in a down market. After that, a webinar on January 26th aims to share the various ways in which organizations can extend their overall Oracle technology investment, especially when it comes to making a decision to move to the cloud. It will address such questions as, is a hybrid solution right for my company? And what does a coexist strategy look like? Please visit our website to learn more about and register for these or any of our webinars. Thank you to our audience for joining us, and thanks also to Dan for sharing your knowledge and expertise during this presentation. This concludes today's webinar.